here. I have a triangle here. Theta is in the corner. All right. I've labeled A, B, 1. What would sine of theta be?
Is it b divided by 1?
Yes, very good. B divided by 1. Okay? Because sine, so if I remember, SOHCAHTOA. Okay? So S is for sine, and we're doing O divided by H. O is the opposite side, so B, and H is just 1. Okay, so B divided by 1. Or in other words, just B, right? If I divide something by 1, I just end up with the same number. Okay? Now let's do cos theta. What would cos theta be? Cos theta.
It would be A divided by B.
1.
A divided by 1.
Oh, sorry.
That's
yeah.
okay. Ka, right? So cos is adjacent divided by hypotenuse. So A divided by 1, which simplifies to just A. All right? So A is cos theta and B is sine theta. All right? Now this is an interesting triangle that we're going to use. Imagine I have this triangle, okay? And what we're going to do is, can I shrink this? Oh, no, I can't. What I'm going to do is, imagine that this triangle, all right, is on a numbered plane. Let me make the screen bigger. Imagine this triangle is on a numbered plane. Sorry, guys. Move this guy here, and this guy over here. All right, let's put this on a number plane. Because to help us do non-right angled trig, this is a little trick done by mathematicians. Okay. Imagine this circle has a radius of 1. Okay, imagine this circle has a radius of 1 and it sits on a number plane like this. All right, so this is x and this is y. Oops. This is x and this is the y-axis, okay? This is a little life hack, a little shortcut that mathematicians did to figure out.
Can we copy that?
No, I'm recording this as a video, and I'm going to save it as a screenshot as well for you later. Okay? Because it's going to be a bit hard for you to copy. Just watch and listen. Now, this is a circle of radius 1. Okay? We call this the unit circle. You want to write a heading, a little subheading, you can write the unit circle here. Okay? So unit meaning 1, and circle meaning circle. Now, why do they draw this triangle in a circle? Because if I consider the fact that I only know trigonometry with triangles that have an angle between 0 and 90 degrees, right? So I'm working in this quadrant here, right? If I make theta bigger than 90, I'm going to end up in this quadrant, right? But what happens, for example, if I make an angle going like this, oops, onto this side to kind of reflect the exact same shape, the exact same triangle, okay, but on this side. So now look at this yellow triangle. I've tried to copy it so that this angle theta is the same. This angle theta is the same. All right, this is the unit circle. If I just consider the size of these sides, what would the length of the hypotenuse be if the radius is 1? Well, it will actually still be 1, right? what would this length be on this side? If I
Oh,
triangle,
still A.
A, good, right? And the height of this triangle would still be B, all right? But a strange quirk of trig larger than 90 degrees, right? We are actually going to, look, this is a negative x. So this is actually negative A, correct? And then these mathematicians are like, well, I can actually do the same if I go down this way. I can keep the same angle, right? I have negative A. This is still 1, right? The radius is still 1. I haven't changed, okay, the size of the circle. And the y coordinate is actually now minus B. See that? They've kept theta the same, but they're just changing this coordinate system. And then one more triangle over here. See this? I'm trying to keep this angle the same, and I'm saying, oh, actually, now this is minus B and plus A. Right, so it's an interesting pattern. Remember, math's all about finding the patterns. And they realized that they could create a way of doing trigonometry larger than 90 degrees by using this coordinate system, okay, called the unit circle. And we do it by quadrants, okay? This is quadrant 1. Oops, this is quadrant 1. Call this quadrant 2. This is quadrant 3. This is quadrant 4. All right. But for now, the important thing to realize, actually, right, is that sine theta in the unit circle is actually just B. Now, ignoring the fact that this is a triangle or a unit circle, and let's just think about the fact that this could be a point, right? This could be a point on the circle. Ignore the triangle for a second. Let's call this a point P. All right, based on these labels, what would the coordinate of this point P equal? What would the coordinate, what would the position, what's the x position of this point? This is x, right? And this is y. So the coordinate would just be?
A and B.
AB, very good, Krista. Okay, this is very advanced maths, guys, so pay attention. I'm going nice and slow. All right, so on this unit circle, right, if you see the point P and it has a position AB, right, because using the unit circle and the hypotenuse is 1, sine of theta is the y coordinate and cos of theta is the x coordinate. All right, so we're going to work with that for the next few lessons. So in a unit circle, you write this one down. Okay, in a unit circle, the point P has the x coordinate, or has an x coordinate, equal to sine theta. I don't have the theta symbol, so just write that. And sorry, it should be cos theta for x. And a y coordinate equal to sine theta. Okay. In the unit circle, the point P, so P can be anywhere in the unit circle. I could put point P here, we'll point P here, 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 whatever, okay? Now, why do we use this? It will become a bit clearer in more lessons, okay? But let's look at an example. I'll give you a minute to have a look at this circle. Okay, because eventually what's going to happen, guys, is imagine this line, and it's going to go all the way around the circle. We're going to get all kinds of different trig functions, trig values, okay, for any angle, not just between 0 and 90. Okay, so it's really cool what actually happens. And you will actually see why it's called a sine function, actually. Okay. So if none of that made any sense, that's okay. The important thing is, yes, Vojta.
Could you just keep it there for a second?
Okay, yeah. The important thing is right now, if you see a unit circle with a point P, the y coordinate, okay, is sine theta. The x coordinate is cos theta. Okay. If none of that made sense, at least take this point away today. All right, I'll keep it there for a second. If you want to try and copy this down, then go for it. But
yeah, I'm trying.
That's okay.
But I also took a screenshot, so if you want to go on, that's fine.
Good, good. Okay, I have also saved it. So if you look in the textbook, this is what it looks like, okay? Dun, 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 dun. Boom, boom. Okay. So here's a unit circle, right? You have x and y. So we're just going to stick in the first quadrant for now. Okay. We're going to state exactly the coordinates of point P. All right. I have a unit circle, a circle of radius 1. Okay. And I have an angle 72. Okay. So the exact coordinates, well, I just said the x position is cosine theta, right? So cosine theta is just cos 72. And then y is sine 72. Ta-da! That's it. And then to find the coordinates to 3 decimal places, you just put that into your calculator. All right. So why don't we just practice using our calculators with Trig? Can you get your calculators out, please, and press cos 72 and sine 72 and see if it matches these two coordinates, okay? If it doesn't, it may mean you're in the wrong calculator mode.
I got like negative 0.96.
So, Martina, can you go into your mode menu, or is there a mode button? What button is
Oh yeah, I see. Yeah, mode, and then it's like, let me just show you. It does like this.
So you need to go down to, do you see radian? So go down to radian and change it to degrees. So radian is like the third or fourth one down, and you go to degrees instead. Yep. So go to degrees and press enter.
Okay, thank you.
Okay. So now you should get 0.309 and 0.951. Okay, so that's it, guys. Point P has the position cos theta and sine theta. Okay, for now, it doesn't really make sense why we do that, but it all comes together once we look at the other quadrants as well, okay? Why don't we try this one together, okay? Oh, let me zoom out a bit. Okay. So angle TOP is 28 degrees and TOQ is 68 degrees. What are the exact coordinates of P and Q? Okay, and then find them corrected 3 decimal places. Very easy. It's exactly the same as one above. What would the x coordinate of P be? Oh, excuse me. Well, x is what? Cos or sine? This angle here is 28.
Oh, it's true. I think